A common problem that developers run into when writing tests has to do with shared setup and teardown logic, especially when there's a perceived parent-child relationship between the tests themselves. Some tests share the same setup logic, but then differ in the details. This holds especially true when designing a class according to the behavior-driven development style, or BDD for short. A test declaration here is split into 3 parts: given, when, and then, each with a specific pre-configuration applied in order to work. There might be different whens next to each other in the same class, but they don't exactly share 100% of the setup logic, so single before each method just won't cut it completely. Let me show you what I mean, because JUnit Jupyter has a very elegant solution for sharing state between parent classes and their children, in the form of the @nested annotation. This annotation is used exclusively for inner classes of a test class, and it ensures that the lifecycle of the parent is woven into the lifecycle of its children. Let's develop an example of a BDD-style test using JUnit Jupyter and the @nested annotation. We want to test how a session in our application behaves in a relation to a deck of cards. Starting with the outer class, we initialize a common value, the deck, in the parent's @beforeEach method. This will ensure that all test methods get their hands on a fresh deck instance when executing. Next, we create another class inside this class and call it session_turn_tests. The test methods inside this child class will access the outer deck object, so it's important that this child class is not a static class. In Kotlin, this is achieved through the inner modifier on the child class declaration. Lastly, we slap the @nested annotation on top of the child class, which is the magic glue that tells Jupyter that this child class has to be integrated into its parent's lifecycle. After setting up the inner class, we continue with the setup phase of this child by adding another set of lifecycle methods here. Think of this inner class as an isolated group of tests within the context of its parent. Test methods outside this inner class will not get the second lifecycle. However, the test methods inside this inner class will get the first lifecycle. We are going to have a more visual look at this in a second. For now, let's create an actual @test method in the inner class and add some logic here that uses both the deck object from the parent as well as the session object created inside the inner class. As a last step, and for the sake of visualizing the interconnectedness of the two classes, I will add some log statements into each of the methods we just created. It will help demonstrate the order of execution and show how nested actually works. So finally, let's execute this class. You can see that in the IDE, a tree-like structure is generated, with the child class methods sitting comfortably inside their parent's declaration. When we check the standard output, you can see how the outer lifecycle wraps around the inner lifecycle, and finally the test method's output itself. This is all thanks to Nested.